For centuries, humanity has looked toward the stars with wonder. Ancient civilizations believed the heavens were eternal and unchanging, a perfect cosmic design stretching infinitely above Earth. But modern science has revealed a far stranger truth. The universe is alive with motion. Galaxies drift apart, stars are born and die, and space itself continues to expand every second. Today, astronomers are witnessing discoveries so unusual that they are forcing scientists to reconsider long-held ideas about the cosmos. At the center of this scientific revolution is the James Webb Space Telescope, one of the most advanced observatories ever created. Built to peer deeper into space than any previous telescope, Webb was designed to capture ancient light from the earliest galaxies in the universe. Orbiting far beyond Earth, its infrared instruments can detect wavelengths invisible to human eyes, allowing scientists to look billions of years into the past. What Webb discovered shocked researchers across the globe. While studying extremely distant galaxies, astronomers noticed that some regions of space appeared unexpectedly dim. In several cases, galaxies that should have contained vast numbers of visible stars looked strangely faint or partially hidden. Online rumors quickly exaggerated these observations into claims that hundreds of trillions of stars vanished, creating dramatic headlines across the internet. The reality is more scientific, but no less fascinating. Scientists now believe the mystery may be connected to the expanding nature of the universe itself. To understand this, we first need to understand how light travels across cosmic distances. Light moves incredibly fast, traveling nearly 300,000 kilometers every second. Yet the universe is so enormous that even light takes billions of years to cross it. When astronomers observe distant galaxies, they are not seeing them as they exist today. They are seeing ancient light that left those galaxies long ago. A galaxy located 1 billion light-years away appears to us as it looked 1 billion years in the past. But there is another complication. The universe itself is expanding. This idea was first discovered in the early 20th century when astronomers observed that distant galaxies were moving away from us. The farther away a galaxy was, the faster it appeared to recede. This became one of the strongest foundations of the Big Bang theory, the idea that the universe began in an extremely hot, dense state and has been expanding ever since. As space expands, light traveling through it also stretches. Scientists call this phenomenon redshift. In simple terms, light from distant galaxies becomes stretched into longer wavelengths during its journey across the universe. Visible light can eventually shift into infrared radiation, making galaxies appear dimmer or harder to detect. This is why the James Webb Telescope was built primarily as an infrared observatory. It allows astronomers to observe ancient galaxies whose visible light has stretched far beyond normal detection ranges. Yet Webb's observations revealed something unexpected. Some early galaxies appear far more mature and massive than current theories predicted. According to standard cosmology, galaxies in the early universe should have been small and chaotic. Instead, Webb detected structures that seem surprisingly developed only a short time after the Big Bang. This discovery triggered intense scientific debate. Some researchers argue that galaxy formation happened much faster than previously believed. Others suggest that our understanding of dark matter may be incomplete. A few even question whether certain cosmological models need revision. However, scientists stress that these findings do not disprove the Big Bang theory. Instead, they reveal gaps in our understanding of how the early universe evolved. Another mystery deepens the story even further: dark energy. Modern observations suggest that ordinary matter, everything we can see, including stars, planets, and galaxies, makes up only a small fraction of the universe. Roughly, 5% is ordinary matter, 27% is dark matter, 68% is dark energy. Dark matter cannot be seen directly, yet its gravity influences galaxies across space. Dark energy is even stranger. Scientists believe it may be responsible for the accelerating expansion of the universe. In other words, galaxies are not just moving apart. The rate of expansion itself is increasing. That realization changes everything. As the universe expands faster and faster, distant galaxies slowly drift beyond our reach. This does not mean the galaxies physically disappear. Instead, space between us and those galaxies stretches so rapidly that their future light can no longer travel toward Earth. Eventually, they fade beyond the observable horizon of the universe. Imagine standing on a shoreline while ships sail away across an endless ocean. At first, you can still see them clearly. But as distance increases, they become tiny points before vanishing beyond the horizon entirely. The ships still exist, you simply can no longer observe them. The same thing may be happening across the cosmos. Some scientists estimate that many galaxies visible today will eventually become permanently unreachable. Future civilizations, billions of years from now, may see a far emptier universe than we do today. This possibility creates one of the most haunting ideas in modern astronomy. Humanity exists during a rare cosmic era when we can still observe much of the universe. Over immense stretches of time, distant galaxies may fade into darkness as their light becomes infinitely redshifted. V equals h0d. V equals h_0d. V equals h0d. This relationship, known as Hubble's law, explains how galaxies farther away move faster due to cosmic expansion. The implications are staggering. In the far future, observers inside our local group of galaxies may no longer detect evidence of the Big Bang at all. The cosmic microwave background radiation could become too faint to observe. Distant galaxies might disappear entirely from view. Civilizations living trillions of years in the future may believe their galaxy is the entire universe. For modern humanity, this realization is both unsettling and inspiring. It reminds us that science is not static. Every generation uncovers discoveries that challenge previous assumptions. The universe continues to surprise us in ways no one expected. Naturally, these mysteries also inspire speculation. Some theories imagine unknown cosmic processes affecting stars and galaxies on enormous scales. Others wonder whether advanced civilizations could manipulate energy beyond our understanding. While such ideas remain speculative, they reflect humanity's deep desire to understand the unknown. But science advances through evidence, not fear. Astronomers continue studying Webb's data carefully, searching for explanations grounded in physics and observation. Every image captured by the telescope offers another clue about the birth of galaxies, the behavior of black holes, and the structure of space itself. Perhaps the greatest lesson from these discoveries is perspective. Earth is only a tiny world orbiting an ordinary star within one galaxy among billions. Yet somehow, intelligent life emerged here and developed the ability to study the universe itself. Humanity built machines capable of looking back through cosmic time, observing light older than our planet. That achievement alone is extraordinary. The cosmos remains filled with unanswered questions. We still do not fully understand dark matter, dark energy, or the ultimate fate of the universe. But every discovery pushes the boundaries of human knowledge a little further. And maybe that is what truly matters. Not whether the universe is frightening or mysterious, but that we continue exploring it. Because every distant galaxy, every fading star, and every beam of ancient light carries another piece of the story we are trying to understand, the story of the universe, and our place within it.